We'll start in 1 minute. Today we're going to cover section 9.1. This is not on going to be on test 3. Test 3 is only over chapter 7 and 8. But today and tomorrow we'll cover section 9.1 today and section 9.2 tomorrow. And then Wednesday and Thursday we will review for test 3. There are already videos on YouTube with test 3 material. There's the Math 1108 test 3 review sheet videos, and then there are also the Math 1108 chapter 7 and chapter 8 material, test 3 material. And our test review on Wednesday and Thursday, most of the examples will be different than the examples that you encounter in these other videos. There will be a small number that are the same, but most of them are different. So there's a lot of opportunities to get practice for test 3. We need to have higher security when taking quizzes and tests. So tomorrow we're going to have a Zoom meeting trial run. I'll send you an email about that later today and tell you all of the specifics. But for now, let's go ahead and start section 9.1. Okay, in section 9.1, we will discuss how to solve quadratic equations using the square root property. Here's a definition of the standard form of a quadratic equation. The standard form of a quadratic equation in the variable x is ax to the second plus bx plus c equals 0, where a, b, and c are constants and a is not 0. So in other words, a, b, and c just represent real numbers. They are a and b are the coefficients of x squared and x respectively, and then c is a number. Some examples of quadratic equations in the variable x that are in standard form. This example, 3x to the second minus 2x plus 1 equals 0. In this equation, the value of a is 3, the value of b is negative 2, and the value of c is positive 1. In the next example, negative 2x squared plus 7x minus 5 equals 0. This is in standard form. The value of a is negative 2, the value of b is 7, and the value of c is negative 5. If you encounter a quadratic equation that is not in standard form, it can be written in standard form. In these examples, we'll rewrite each of these quadratic equations so that each one is in standard form. So on the left, we have negative 2x plus 5x squared, and that's equal to negative 7. So the standard form, the x squared term is farther to the left. So we'll write it as 5x to the second, followed by minus 2x. And then if we add 7 to both sides, then the right-hand side will be 0. And this is now in standard form. The value of a is 5, b is negative 2, and c is positive 7. Okay, in the next example, this time we have negative 4x squared plus 9 equals negative 12x. I'm going to rewrite this in standard form in two ways that are equivalent to each other. The first way, I'm just going to add 12x to both sides and put the positive 12x in between the x squared term and the constant 9. Okay, so this is now in standard form, and this is a perfectly fine way to write it in standard form. But since we have an equation, we are permitted to multiply every term on both sides by the same non-zero number. We're not allowed to multiply both sides by 0, but we are allowed to multiply every term on both sides by the same non-zero number. Oftentimes, it's more convenient if the coefficient of x squared is positive. So if we multiply every term on both sides by negative 1, we get the quadratic equation positive 4x to the second minus 12x minus 9, and 0 times negative 1 is 0. So these two equations, even though they look a little bit different, the solutions to each of those is the same as, or are the same as the solutions to the other. And as you'll see later on in a few days, that it's often more convenient when the coefficient of x squared is positive. Okay, one more example where we'll write a quadratic equation in standard form. So we have a couple of options as we saw in the prior example. So one way to do it is just to add 8x squared to both sides and subtract 6x from both sides and leave the negative 7 on the left-hand side. So if we add 8x squared, we have 8x squared on the left-hand side, subtract 6x from both sides, and we leave this already there, but we write it as minus 7. And this is now it's in standard form. It's okay if 0 is on the left-hand side and the trinomial is on the right-hand side. So we could do that here. We could make the left-hand side 0 by adding 7 to both sides. So we'll add 7 to both sides, and we will also rearrange the terms on the right-hand side. So instead of 6x minus 8x squared, we'll write it as negative 8x squared plus 6x, and then we're adding 7 to both sides. So these two equations have the same solutions. And so you can write each of those in standard form. Either way is acceptable. And now we'll talk about the square root property itself. Okay, here's the square root property. If x to the second equals k, then the two solutions for x are x equals the square root of k, or x equals the negative of the square root of k. There's an alternative notation. It's okay if you list the solutions separately, positive square root of k and negative square root of k, but you can also list them all at once. If x squared equals k, then the solutions are x equals positive and negative square root of k. Okay, so we'll practice the square root property on some fairly simple examples, and then we'll progress to more difficult examples. In this first one, x to the second equals 81. You can, without writing anything down, we can think of two solutions for x. We know that 9 to the second power equals 81. So x equals 9 as a solution. We also know that if we square the number -9, we also get positive 81. So we really know without writing anything down that 9 and -9 are both solutions. But we're here to practice the square root property. So if x squared equals 81, then we can write x equals positive and negative square root of 81. And then we always want to simplify square roots when possible. So we can write the solutions as positive and -9. Okay, this is a fine way to write the solutions. If you want to write them separately, you can. Writing them separately, x equals positive 9, and the other one is x equals 9. Okay, for this equation, y squared equals 13. The y squared is by itself, so if we just apply the square root property, we get y equals positive and negative square root of 13. The square root of 13 cannot be simplified any further, so we're finished finding the solutions for y on this one. Okay, the next example is a little more involved, but note that we have a binomial squared equals 16. So we can apply the square root property to this. If y plus 3 quantity squared is equal to 16, then y plus 3 equals positive and negative square root of 16. We can simplify the square root of 16 to 4, and then we're also going to subtract 3 from both sides. So what I do next, I'll do both of those things in the next step, but when I subtract 3, it's more conventional to put this number that we're moving to the right-hand side. I'll write it as -3, write it to the left of plus and minus 4 because the square root of 16 is 4. But we can simplify further because both of those are just integers. So we'll write the solutions separately because they simplify further. So one solution is y equals -3 minus 4, or y equals -7. And then the other solution is y equals -3 plus 4. -3 plus 4 is positive 1. So the two solutions don't involve square roots because they all simplified. Well, let's move on to the next one. So here we have the binomial x minus 5 squared equals 17. And since we have the binomial squared equals 17, we can apply the square root property directly. So if x minus 5 quantity squared equals 17, apply the square root property, we get x minus 5 equals positive and negative square root of 17. The square root of 17 cannot be simplified further. And so when we solve for x, we have to add 5 to both sides. So as I mentioned in the previous example, the more conventional way is to put the positive 5 to the left of the positive and negative. And so this is 5 plus and minus the square root of 17. This is a perfectly fine way to write the solutions, but I'll write them separately just so you can know what to expect. One of the solutions is 5 minus the square root of 17. The other solution is 5 plus the square root of 17, if you write them separately. Okay, so we're getting in the hang of this. Some of the next examples won't be that much more difficult, if at all. So this one, 49x to the second equals 169. So in this case, I would advise dividing both sides by 49 first and writing it as x squared equals 169 divided by 49. And then apply the square root property. So we get x equals positive and negative square root of 169 over 49. Well, it's not necessary, but I'll rewrite the square root of the fraction as the square root of the numerator of the fraction divided by the square root of the denominator. And the square root of 169 is just 13. And in the denominator, the square root of 49 is just 7. So one of the solutions is positive 13 over 7, and the other solution is negative 13 over 7. It's okay if you want to just simplify directly the square root of 169 over 49. So directly, the square root of that fraction simplifies to 13 over 7. Okay, in the next example, we have negative 4y to the second equals negative 24. So on this one, what we want to do is divide both sides by negative 4 first. And when we divide both sides by negative 4, we get y to the second equals 6. Because negative 24 divided by 6, negative 24 divided by negative 4 is 6. Okay, now we can apply the square root property. Since y squared equals 6, we can write y equals positive and negative square root of 6. Okay, the next two examples are very similar to some of the ones that we've already done, so we can do these pretty quickly. The quantity y plus 4 squared equals 25. Apply the square root property, we get y plus 4 equals positive and negative square root of 25. Then we're going to subtract 4 from both sides, and we'll write it as y equals negative 4 plus and minus 5, because the square root of 25 is 5. And we can simplify the solutions further because both of those numbers are integers. So one solution is y equals -4 minus 5, or y equals -9. The other solution is y equals -4 plus 5, which is y equals +1. Okay, one more example on this page. The binomial x minus 7 to the second equals 29. Apply the square root property, and we get x minus 7 equals positive and negative square root of 29. And then add 7 to both sides. The conventional way is to write it as x equals +7 plus and minus the square root of 29 for the two solutions. The square root of 29 cannot be simplified further. Okay, we'll do even more examples. Some will be slightly more involved. Okay, the directions say solve the following equations using the square root property. Well, this time we have x to the second minus 45 equals 0. Before we can apply the square root property, we have to add 45 to both sides. So we get x squared equals 45. And now it becomes more familiar with what to do. Since x squared equals 45, we can apply the square root property and get x equals positive and negative square root of 45. And we can simplify the square root of 45 further. So we have to simplify square roots when possible. So x is equal to positive and negative. And instead of the square root of 45, the largest factor of 45 that's a perfect square is 9. 9 times 5 is 45. So this is positive and negative square root of 9 times the square root of 5. And then simplify further, positive and negative 3 times the square root of 5. If you want to write the solution separately, you can. One of the solutions is -3 times the square root of 5. The other solution is +3 times the square root of 5. Okay, this one was slightly more involved, but not by much. Okay, in the next example, 3 times this, the quantity x minus 4 squared equals 150. So we want to divide both sides by 3 to start with, because we want to isolate the x minus 4 quantity squared part. Okay, so we'll divide both sides by 3, and we get the binomial x minus 4 squared equals 50. And now we can apply the square root property. Okay, so when we apply the square root property, we get x minus 4 equals positive, whoops, I need an equal sign, equals positive and negative square root of 50. And the square root of 50 can be simplified further. And we also have to add 4 to both sides. So I'll do two things at once, and then in the next step, I'll add 4 to both sides, so I get x equals 4, and then plus and minus. And then when we simplify the square root of 50, with a little bit of practice, you can just tell what the square root of 50 is going to simplify to. It's going to simplify to 5 times the square root of 2. And that's fine if you see it, but I'll go ahead and write it in a little more detail right now. The largest factor of 50 that's a perfect square is 25. So the square root of 50 is the square root of 25 times the square root of 2. And then in the next step, we'll simplify the square root of 25 to 5. So our two solutions are x equals 4 plus and minus 5 times the square root of 2. Okay, the next one is a little more involved. The first step is not different, but what follows will be a little different than what we've seen. Since we have a binomial 7x plus 1 squared equals 48, this is all set up to apply the square root property. So when we apply the square root property, we get 7x plus 1 equals positive and negative square root of 48. Okay, so to write down the two solutions for x, three things are going to happen. We have to simplify the square root of 48. We have to subtract 1 from both sides. And then the last thing we'll do is divide every term on both sides by 7. Okay, so I'll write a little more detail than is absolutely necessary. I'll just leave 7x plus 1 on the left-hand side for now and work on simplifying positive and negative square root of 48. The largest factor of 48 that's a perfect square is 16. 16 times 3 is 48. So we can write this as positive and negative square root of 16 times the square root of 3. And then in the next step, I'll write 7x plus 1 equals positive and negative 4 times the square root of 3. Okay, then in the next step, we'll subtract 1 from both sides. That means we get 7x equals negative 1 plus and minus 4 times the square root of 3. And then finally, we'll divide every term on both sides by 7. 7x divided by 7 is just x. And we can write the entire expression negative 1 plus and minus 4 times the square root of 3. We can put the whole thing in the numerator and make the denominator 7. Okay, this is a fine way to write the solutions. But I will write them separately just for practice. One solution is x equals, in the numerator, negative 1 minus 4 times the square root of 7. Sorry, negative 1 minus 4 times the square root of 3, all divided by 7. And then the other solution, x equals negative 1 plus 4 times the square root of 3, all divided by 7. Okay, the next one is similar to the one we just did. This is all set up to apply the square root property. So we'll do that. Since the binomial 8y plus 5 quantity squared equals 50, then 8y plus 5 equals positive and negative square root of 50. Just solve for y. We have three things, in effect, left to do. We have to simplify the square root of 50. We have to subtract 5 from both sides. And then we have to divide every term on both sides by 8. So we're starting to get used to this. So in the next step, I'll do a couple of things. I'll subtract 5 from both sides and then start simplifying the square root of 50. So we get 8y equals negative 5 plus and minus. The square root of 50 is the same as the square root of 25 times the square root of 2. In the next step, I'll do two things. I'll simplify the square root of 25 to 5, and I'll also divide every term on both sides by 8. So we get y equals negative 5 plus and minus 5 times the square root of 2, everything divided by 8. Okay, we'll do a few more examples. The next ones will be a little different. But just remember, in this course, everything works out pretty nicely. So this equation doesn't appear to be anywhere near applying the square root property. Well, it's not too far away, but it's not apparent, at least when you look at it to start with. Okay, so what we're going to do, and you can learn with practice. I see I didn't type this correctly from what I intended. We could still solve that, but let's rewrite this as 3y to the second minus 6y plus 3 equals 3. So I'm just replacing the minus 2y with minus 6y. So what we can do is we can divide every term on both sides of this equation by 3. And we get y squared minus 2y plus 1 equals 1. And then I'll remind you of something that is sort of a common topic in Math 1108. The left-hand side is a perfect square trinomial, y squared minus 2y plus 1. When you factor a perfect square trinomial, the factors are identical. And if you multiply two factors that are the same, you can write it as one factor raised to the second power. Okay, so we'll just factor the left-hand side. You could use the AC method to do it, but you can also just note, this is pretty straightforward to find that y minus 1 times y minus 1 equals y squared minus 2y plus 1. You can multiply those factors and verify that the product is the perfect square trinomial. Then y minus 1 times y minus 1 is the binomial y minus 1 to the second power. And now we have it in a form that we can apply the square root property, like we did earlier. Okay, so if y minus 1 squared equals 1, when we apply the square root property, we get y minus 1 equals positive and negative square root of 1. The square root of 1 is just 1. So if I add 1 to both sides, we get y equals 1 plus and minus 1. We can simplify further, since both of those numbers are integers. One of the solutions is 1 minus 1, or 0. And the other solution is 1 plus 1, or 2. So in other words, y equals 0 and y equals positive 2 are the solutions. Okay, I'll show you an alternative. I just did this example just to show you how we can use the square root property. But let's begin with this again. And we'll solve this using a method that we've already learned this semester. So let's subtract 3 from both sides of this equation. And when you subtract 3 from both sides, you get 3y to the second minus 6y equals 0. And then we can solve by factoring. We can divide every term on both sides by 3 if you want. It's not required if you're just solving by factoring. But when we solve by factoring, we want to factor out the greatest common factor of all of the terms. The greatest common factor of these two terms is 3y. So when we factor 3y out, the other factor is y minus 2. And then we can set each factor equal to 0. So 3y equals 0 and y minus 2 is 0. If 3 times y is 0, divide both sides by 3, we get one solution, y equals 0. And if y minus 2 is 0, add 2 to both sides, we get y equals 2. Okay, so it is nice to know that there are often multiple ways to go about solving an equation. Okay, let's do the next one. 3x squared equals negative 75. So before applying the square root property, we should divide both sides by 3. And so we'll get x squared equals negative 25, because negative 75 divided by 3 is negative 25. And now we can apply something that we learned, or that was discussed from section 8.8 on square roots of negative numbers. So this one is x equals positive and negative square root of negative 25. Okay, so what we need to do is one of the things that we have to know for test 3 from chapter 8, section 8. So over here, let's just remind ourselves of how to compute the square root of a negative number like negative 25, square root of negative 25. So you can think of this, the square root of negative 25, as the square root of positive 25 times the square root of negative 1. And we're just applying the product property radicals. 25 times negative 1 is negative 25. And then we can simplify the square root of 25 to 5. And then we replace the square root of negative 1 with the letter I. That's one of our definitions that we're using. I is just defined to be the square root of negative 1. Okay, so up here our two solutions are positive and negative 5i. The solutions are non-real numbers. 5 times I is not a real number. Okay, a couple more examples on this page. This one, the binomial negative 3y plus 4 squared equals 49. This is all set up for us to apply the square root property. So we write negative 3y plus 4 equals positive and negative square root of 49. Hey, we can simplify the square root of 49 to 7. So let's do that before we move any of these terms on the left-hand side. So we'll write it as negative 3y plus 4 equals positive and negative 7. Okay, then we'll subtract 4 from both sides. So we get negative 3y equals negative 4 plus and minus 7. We have a couple of options on how to proceed. Negative 4 plus and minus 7, those two numbers can be simplified because they're both integers. So we can write negative 3y equals one of those numbers, like negative 4 minus 7 is negative 11, together with negative 3y equals positive 3, because negative 4 plus 7 is 3. We can do that first, or if you prefer, we can divide everything on both sides by negative 3 first, and then deal with writing the numerators separately. So it's a toss-up. What I'm going to do, though, is I'm going to leave the left-hand side as negative 3y, and then write two equations where negative 3y equals negative 11 in one case, and then in the other case, negative 3y equals positive 3. So once again, the negative 11 comes from negative 4 minus 7, and the positive 3 comes from negative 4 plus 7. And now we can divide both sides of each of those two equations by negative 3. So for this one, negative 3y equals negative 11, divide both sides by negative 3, we get y equals positive 11/3 for one of the solutions. And then the other solution, if negative 3y equals 3, divide both sides by negative 3, we get y equals negative 1. So those are the two solutions. Okay, we have one more example from this section, and then I'm going to review the answers to quiz 8. So on this one, this is all set up to apply the square root property. So we can write negative 5x plus 3 equals positive and negative square root of 64, and that simplifies to 8. So in the next step, I'll do a couple of things. Negative 5x equals negative 3 plus and minus 8. So we have a situation similar to the previous example. This time I'll do it a little differently. I'll divide every term on both sides by negative 5 first. So x equals negative 3 plus and minus 8, all divided by negative 5. But we can simplify further, and so that means we do have to write the solution separately. So one of the solutions, we can start out by writing x equals negative 3 minus 8, all divided by negative 5, and then do the arithmetic. In the numerator, negative 3 minus 8 is negative 11. In the denominator, negative 5. And negative 11 divided by negative 5 is positive 11/5. And then the other solution, x equals negative 3 plus 8, all divided by negative 5. So in the numerator, negative 3 plus 8 is 5. We're dividing by negative 5. So the other solution is negative 1. Okay, there's about 10 minutes left. I'm going to do the problems on quiz 8 that you took last week. So quiz 7 and quiz 8 had problems where you solve equations with rational expressions. And some students are making the same mistakes all the time. And so if you study the answers that I send in the emails, that can help you perhaps overcome making the same mistakes over and over again. Okay, so on this one, we identify the restricted values. X plus 2, that's 0 when x is negative 2. So we say x can't be negative 2. Negative 2 is restricted. X plus 6, that's 0 when x is negative 6. So the other restricted value is negative 6. Okay, the next thing that you do is identify the least common denominator, which is the least common multiple of the denominators. And it turns out that the denominator x squared plus 8x plus 12 is equal to x plus 2 times x plus 6. So you can write the least common denominator in factored form, you can write it as x plus 2 times x plus 6. If you prefer, you can write it in expanded form, x squared plus 8x plus 12. Okay, what you do with the least common denominator, the whole reason that we're finding the least common denominator is so that we can get rid of the denominators from this equation. So we're going to multiply each term on both sides of the equation by the least common denominator. So it's called the least common denominator, but when we use it, it's going to be in the numerator. We're going to write the least common denominator in the numerator and multiply each of those three terms on both sides by the least common denominator. So this is emphasized when I say, think of x plus 2 times x plus 6 as x plus 2 times x plus 6 over 1. The least common denominator is in the numerator. And also you can write x squared plus 8x plus 12 over 1. Okay, so I'm going to multiply the left-hand side by the expanded form because the denominator is in expanded form. So I write x squared plus 8x plus 12 over 1 multiplied by x minus 10 over x squared plus 8x plus 12 on the left-hand side. On the right-hand side, I'm going to use the factored forms because this denominator has one of the factors x plus 2 in it. So I multiply that term by x plus 2 times x plus 6 over 1 times 3 over x plus 2. And then we multiply the third term on this term over here on the far right, multiply that by the least common denominator, x plus 2 times x plus 6 over 1 times 4 over x plus 6. Okay, the whole reason that we're doing this is so that we can get rid of the denominators. More precisely, we're reducing every denominator to a factor of 1. So in this first product, this trinomial factor divided by the same trinomial factor equals 1. So those cancel each other out. So now we're just left with x minus 10. This has a denominator of 1, but when the denominator is 1, we don't need to write it. So this is referred to as clearing the denominator. And then in the next product, we're clearing the denominator again, but this time it's x plus 2 divided by x plus 2. And now we just have x plus 6 times 3. And then in the final product over here on the right, the x plus 6 from the numerator divided by x plus 6 from the denominator, those cancel. So we cleared that denominator, and now we just have x plus 2 times 4. This equation is a lot easier to solve than the one we first looked at. So we'll just do the algebra and arithmetic, x minus 10, and then apply the distributive property equals 3x plus 18. Apply the distributive property here, so plus 4x plus 8. We'll combine like terms on the right-hand side. So x minus 10 equals 7x plus 26. So in the next step, I'll subtract x from both sides. So we get negative 10 equals 6x plus 26. And then subtract 26 from both sides. Negative 10 minus 26 is negative 36. equals 6 times x. And finally, we can divide both sides by 6. Negative 36 divided by 6 is negative 6. So our candidate for a solution is x equals negative 6. But negative 6 is a restricted value. So we have to say that there's no solution. No solution because negative 6 is a restricted value. Okay, so we're down to less than 2 minutes, about a minute and a half. So all of those answers to quizzes that I've sent you, study those, especially the ones that are related to the test 3 over chapters 7 and 8. There have only been a couple of quizzes over that material, but I guess I'll just keep working until time runs out. We have about a minute. This is a problem that involves rate times time equals distance. And Janet traveled a distance of 105 miles in the same time that Julie traveled a distance of 120 miles. Julie's speed was 5 miles per hour faster. That's supposed to be faster than Janet's speed. So if x is Janet's speed and t stands for time, then Julie's speed is x plus 5 times t. The key here to note is that the t values are equal because they traveled the same time. So if we solve for t, time for Janet is 105 divided by x. Time for Julie is 120 divided by x plus 5. And then the times are the same, so the equation to solve is 105 over x equals 120 over x plus 5. Okay, we're now out of time, but apply what you know on how to solve equations with rational expressions with this one. Okay, that's all for today. Today we'll cover section 9.1, solving quadratic equations using the square root property. Test 3 is this Friday. It will be over chapters 7 and 8. And we will review for test 3 tomorrow and Wednesday. There are 2 playlists on YouTube that cover the test 3 material. One of those is the Math 1108 Test 3 review sheet videos. And then the other playlist is Math 1108 Chapter 7 and Chapter 8 material, Test 3 material. And we need to have higher security when taking quizzes and tests. So I'll explain in an email later today how we're going to have a multiple Zoom meeting trial run tomorrow. Probably at the last part of, or right after class, the last 10 minutes before 10 or so. Okay, but today we're going to cover section 9.1. Okay, solving quadratic equations using the square root property. You've seen quadratic equations before. The standard form of a quadratic equation in the variable x is ax squared plus bx plus c equals 0, where a, b, and c are constants, and a is not equal to 0. Okay, so the variable is x, and a, b, and c are just real numbers, or they represent real numbers. Examples of quadratic equations in the variable x in standard form. Well, if it's in standard form, there's always 0 on one side. And this is in standard form, 3x to the second minus 2x plus 1 equals 0. In this equation, a is 3, b is negative 2, and c is positive 1. So if it's in standard form, the x squared term is farthest to the left, the x term is in the middle, and the constant real number is on the right. Okay, in the next example, negative 2x squared plus 7x minus 5 equals 0. This is in standard form, and the value of a is negative 2, the value of b is positive 7, and the value of c is negative 5. You will perhaps encounter quadratic equations that are not in standard form, but you can always write them so that they are in standard form. We'll look at 3 examples. And in each of these, we will rewrite it so that it's in standard form. We're starting out with negative 2x plus 5x squared equals negative 7. Okay, so we have 2 things to do to get this into standard form. We're going to put the plus 5x squared term all the way to the left, or just 5x to the second. And then instead of negative 2x, we're going to subtract 2x right after 5x squared. And then we're going to add 7 to both sides so that the right-hand side is 0. So this is now in standard form. The value of a is 5, the value of b is negative 2, and the value of c is 7. Okay, the next example, I'll show you two equivalent ways to write this equation in standard form. You have the same two options regardless of what the quadratic equation is. But on this one, we can get this into standard form if we just add 12x to both sides and put the x term in between the x squared term and the constant. So in one step, we can write it in standard form as negative 4x squared plus 12x plus 9 equals 0. Okay, so this is a fine way to write it in standard form. But oftentimes, it's more convenient if the coefficient of x squared is positive instead of negative. And since this is an equation, we are free to multiply every term on both sides of this equation by the same non-zero number. We are not free to multiply both sides of an equation by 0, but if it's non-zero, it's okay because we're just multiplying both sides by the same non-zero number. So if we multiply every term on both sides by negative 1, we get positive 4x squared minus 12x minus 9. 0 times negative 1 is still 0. These don't look the same, but the solutions to each of those two equations are the same. And as I mentioned, you might find it easier if the coefficient of x squared is positive instead of negative. So consider that an option when dealing with quadratic equations. Okay, and the next one, we can write this in standard form in one of two ways. Perhaps the most obvious thing to do is add 8x squared to both sides and subtract 6x from both sides. And so if we add 8x squared to both sides, we have 8x squared, and then we're going to subtract 6x from both sides to get 8x squared minus 6x. And we already have negative 7 on the left, so this is this minus 7 equals 0. Okay, that's fine. It's okay if 0 is on the left-hand side and the trinomial is on the right-hand side. That's still considered standard form. So if you want, you can just make the left-hand side of this equation 0 by adding 7. So if we add 7 to both sides, the left-hand side will be 0. But then we'll rearrange the terms so that the first term on the right-hand side is negative 8x squared, and then plus 6x, and then we're adding 7, so it's plus 7. So an important thing to remember is that the solutions to each of those two equations are the same. Okay, now we're ready to talk about the square root property and how to solve quadratic equations using the square root property. Okay, the square root property. You already know something about this just by experience. If x squared equals a number k, then x is equal to the square root of k, or x is equal to the negative square root of k. An alternative notation, if x squared equals k, then x equals positive and negative square root of k. So if you're saying that the solutions are positive and negative square root of k, then you can use the word and if you're just listing the solutions. Okay, so let's try out the square root property with some fairly simple examples to start with. And some of these you know just right off write off what the solutions are. Solve x squared equals 81. We can think of a number to square to get 81. If you square the number 9, you get 81. So 9 has to be a solution. But also, if you square the number -9, you also get 81. Okay, so we can find the solutions to this one without going through the steps. But we're going to go through the steps, and then it will be more useful to go through the steps when the examples get a little more complicated. Okay, so if x squared equals 81, then we write x equals positive and negative square root of 81. And then we always simplify square roots when possible. So we can write the solutions as positive and -9. If you want to list both solutions at once, you can. You can also write them separately. If you write them separately, one solution is x equals -9, and the other solution is x equals +9. Okay, the next example, y squared equals 13. This is all prepared to apply the square root property. So if y squared equals 13, then y equals positive and negative square root of 13. The square root of 13 cannot be simplified further, so this is, we're all finished finding the solutions to that equation. Okay, the next example is a little bit more involved. This time we have the binomial y plus 3 squared equals 16. Since we have a binomial squared equals 16, we can apply the square root property right away. So we write y plus 3 equals positive and negative square root of 16. In the next step, I'll do two things at once in the next step. I'll simplify the square root of 16 to 4, and I'll also subtract 3 from both sides. And it's more conventional when subtracting 3 to write -3 and then plus and minus 4. It's not the only way to do it, it's just more conventional to do it that way. If you look at the textbook material, you'll see the same thing that's done there. But we can simplify further since both of those numbers are integers, so we have to simplify further and write the solutions separately. One solution is -3 minus 4, or -7. And the other solution is y equals -3 plus 4, which is 1. Okay, so to summarize, y equals -7 and y equals +1 are the solutions. Okay, in the next example, this is similar to the one we just did. We have the binomial x minus 5 squared equals 17. So we can apply the square root property, and we get x minus 5 equals positive and negative square root of 17. We cannot simplify the square root of 17 any further, so there's just one step left. We add 5 to both sides. But as in the previous example, it's more conventional to write x equals 5 plus and minus the square root of 17. And you can write the solution separately if you want. I'll go ahead and do that just for practice. One solution is x equals 5 minus the square root of 17. The other solution is x equals 5 plus the square root of 17. Okay, in the next example, 49x to the second equals 169. So on this one, I would advise dividing both sides by 49 first. So we get x squared equals 169 divided by 49. And then apply the square root property. And we can write x equals positive and negative square root of 169 over 49. It's not required, but you can write positive and negative, and then instead of the square root of a single fraction, you can write it using the quotient property of radicals, plus and minus, or positive and negative, the square root of 169 divided by the square root of 49. And the square root of 169 simplifies to 13. 169 is just a perfect square. And in the denominator, the square root of 49 simplifies to 7. So the two solutions are just ordinary fractions, positive and negative 13/7. Okay, in the next example, negative 4y to the second equals negative 24. So on this one, start by dividing both sides by negative 4. And we get y squared equals positive 6. And now there's just one step to finding all of the solutions, both solutions. Apply the square root property, we get y equals positive and negative square root of 6. And the square root of 6 cannot be simplified further, so that represents both solutions. Okay, the next two examples are like a couple of the examples we've already seen. We have the binomial y plus 4 squared equals 25. Apply the square root property, so we get y plus 4 equals positive and negative square root of 25. So in the next step, I'll do two things at once. I'll subtract 4 from both sides and also simplify the square root of 25. So y equals negative 4 plus and minus 5. Since both of those are integers, negative 4 and 5 are both integers, we can simplify further, and we have to write the solutions separately. So one solution is y equals negative 4 minus 5, which is negative 9. And the other solution is negative 4 plus 5, or y equals 1. Okay, the next one, the binomial x minus 7 squared equals 29. So apply the square root property, and we get x minus 7 equals positive and negative square root of 29. And then we can add 7 to both sides, so we get x equals 7 plus and minus square root of 29. The square root of 29 cannot be simplified further, so those are the two solutions. We'll look at some more examples. Some are just a little bit more complicated. In this example, first one at the top, x squared minus 45 equals 0. So we have just a little preliminary work to start with. We have to add 45 to both sides, so we get x squared equals 45. And now we can apply the square root property. So if x squared equals 45, x equals positive and negative square root of 45. The square root of 45 can be simplified. The largest factor of 45 that's a perfect square is 9, so we can write this as x equals positive and negative square root of 9 times the square root of 5. And then finally, x equals positive and negative 3 times the square root of 5. Okay, in the next example, 3 times the binomial x minus 4 squared equals 150. So we should start out by dividing both sides by 3 first. That's the preliminary work to do in this one. So when we divide both sides by 3, we get the binomial x minus 4 squared, and 150 divided by 3 is 50. Now it's all set up to apply the square root property. So we get x minus 4 equals positive and negative square root of 50. In the next step, I'll add 4 to both sides and start simplifying the square root of 50. So this is x equals 4 plus and minus. And then the square root of 50 is equivalent to the square root of 25 times the square root of 2. And the square root of 25 is 5. So our solutions are x equals 4 plus and minus 5 times the square root of 2. And the next example, well, we have a little more to do in this one, but it's all set up to apply the square root property because we have a binomial squared on the left-hand side. So we can apply the square root property right off the bat, and we write 7x plus 1 equals positive and negative square root of 48. Okay, so to complete this, there are essentially 3 steps left. We simplify the square root of 48. We also have to subtract 1 from both sides. And then afterwards, the final thing to do will be to divide every term on both sides by 7. Okay, so I'll write more detail than is absolutely necessary. We'll just simplify the square root of 48 as much as we can. The largest factor of 48 that's a perfect square is 16. 16 times 3 is 48. So in this next step, I'll just write 7x plus 1 equals positive and negative square root of 16 times the square root of 3. And the square root of 16 is 4, so I'll write this as 7x plus 1 equals positive and negative 4 times the square root of 3. Okay, then we'll subtract 1 from both sides, and we get 7x equals negative 1 plus and minus 4 times the square root of 3. Then we'll divide every term on both sides by 7. So 7x divided by 7 is x. And on the right-hand side, we have to divide the entire negative 1 plus and minus 4 times the square root of 3. You have to divide the entire quantity by 7. So I'll go ahead and write the 2 solutions separately. So one solution, so in the numerator, we'll just get one of the solutions as negative 1 minus 4 times the square root of 3. And all is divided by 7. And the other solution, in the numerator, negative 1 plus 4 times the square root of 3. Everything divided by 7. Either way should be okay, but you should know how to write the solutions separately. Okay, the next example is of the same sort as the one we just did. This is all set up to apply the square root property since we have a binomial squared on the left-hand side. So step 1, 8y plus 5 equals positive and negative square root of 50. This time in the next step, I'll do two things. I'll subtract 5 from both sides and also simplify the square root of 50. So we get 8y equals negative 5 plus and minus. The largest factor of 50 that's a perfect square is 25. 25 times 2 is 50. So we'll write this as plus and minus the square root of 25 times the square root of 2. Okay, then in the next step, we'll do two things. We'll simplify the square root of 25 and also divide every term on both sides by 8. So we'll get y equals, in the numerator, negative 5 plus and minus 5 times the square root of 2, all divided by 8. Okay, unless you want to write the solution separately, you can do that, or leave it in this form. This is as far as we can take it. Okay, we'll look at some more examples. These won't be that much more involved, except maybe the first one on the next page. Hey, solve the following equations using the square root property. Continued. This doesn't look like it's set up yet to apply the square root property. And so it isn't. But we'll get it there. 3y to the second minus 6y plus 3 equals 3. Well, there's more than one way to go about solving this equation. And I'll show you an alternative that you already know about. But this is just to demonstrate how the square root property can eventually be applied. So what I'm going to do is I'm going to divide every term on both sides by 3 to start with. And divide every term on both sides by 3, we get y to the second minus 2y plus 1 equals 1. And the left-hand side is a perfect square trinomial. Perfect square trinomials, that's one of the main topics of Math 1108. Perfect square trinomials come up again and again and again. So it's useful to know when you are looking at a perfect square trinomial. When you factor a perfect square trinomial, the two factors are identical. So we know how to factor y squared minus 2y plus 1. You can always use the AC method. But this one is simple enough that you can find that the two factors are y minus 1 times y minus 1. So our equation becomes y minus 1 times y minus 1 equals 1. But y minus 1 times y minus 1 is the binomial y minus 1 squared. And now we have it in a form that we can apply the square root property. So apply the square root property to this. We get y minus 1 equals positive and negative square root of 1. And the square root of 1 is just 1, so I'll add 1 to both sides, and we get y equals 1 plus and minus 1. One of the solutions is y equals 1 minus 1, or 0. And the other solution for y is y equals 1 plus 1, or y equals 2. Okay, so I mentioned that we'll do something that we already know about on how to solve this. So if we start with the original equation, we can start by subtracting 3 from both sides. and write it as 3y squared minus 6y equals 0. And then we can solve by factoring. So since the right-hand side is 0, the first step in factoring, factor out the greatest common factor of all of the terms. The greatest common factor is 3y, 3 times y, so we factor 3 times y out, and we're left with the binomial y minus 2. And since the product of the factors is 0, to find the solutions, we set each factor equal to 0, so 3y is 0. The other factor is a binomial y minus 2, so y minus 2 is 0. On this one, since 3 times y is 0, divide both sides by 3, we get y equals 0. And then the other one, since y minus 2 is 0, add 2 to both sides, we get y equals 2. Okay, so oftentimes there are multiple methods for solving an equation. You're always, in general, you're free to use whatever method you want unless the directions ask you to demonstrate one method. But knowing that there are multiple methods can be useful. Okay, in the next example, solve this equation, 3x squared equals negative 75. So first divide both sides by 3 to get x squared equals negative 25. And now we get to review some of the Chapter 8 material. Section 8.8 had to do with square roots of negative numbers. So we can still solve this. It does have solutions, but we apply the square root property and we get x equals positive and negative square root of negative 25. So over here on the side, let's review what we know about square roots of negative numbers. The square root of negative 25, we can think of this as the square root of positive 25 times the square root of negative 1. We can do this because of the product property of radicals. Since 25 times negative 1 is negative 25, we can write those, each one is equivalent to the other. But simplifying the square root of negative 25 comes down to simplifying the square root of 25 times the square root of negative 1. We can simplify the square root of 25 to 5, and we replace the square root of negative 1 with the letter lowercase I. That's just the definition that we're using for the square root of negative 1. So the letter I probably was used to represent the imaginary unit. So it's probably done for convenience. Instead of writing the square root of negative 1 every time, we just use I in its place. Okay, so our two solutions then are x equals positive and negative 5 times I. The two solutions are non-real complex numbers. Okay, the next example, this will be just a little bit more annoying maybe. Not that hard, just some of the arithmetic. It's not that bad. But we have the binomial negative 3y plus 4 squared equals 49. So this is all set up to apply the square root property. So in step 1, we get negative 3y plus 4 equals positive and negative square root of 49. Okay, so we can simplify the square root of 49 to 7, and we'll subtract 4 from both sides. So let's go ahead and do both of those at once. So we have negative 3y equals negative 4 plus and minus 7. Okay, from here we have a couple of options. Since -4 and 7 are both integers, we're going to have to write the solutions separately when we're all finished. So one option is to first find the two quantities that are equal to -3y. So in one case, -3y is -4 minus 7, or -11. And in the other case, -3y is -4 plus 7. And then just solve each of those for y, divide both sides by -3, y equals positive 11/3. And the other solution is y equals 7 divided by -3, or -7/3. Yeah, this is probably how I would prefer to do it, but there's another option. From this step, you can divide both sides by -3, and you can write it as y equals -4 plus and minus 7, all divided by -3. But as I mentioned earlier, we have to simplify further, and we have to write the solution separately. So on one case, we can write the numerator as -4 minus 7, which is -11, and the denominator is -3, so that simplifies to 11/3. And then the other one, the numerator is -4 plus 7, all divided by -3. So I see I made a mistake earlier. This number over here, this when we were up here, -4 plus 7, this one should be +3. And then when we divide both sides by -3, we get y equals -1. So I hope that didn't ruin the day for you. Okay, then over here, the numerator, -4 plus 7, is +3, and then divided by -3. So we get -1. Okay, just one more example. We have the binomial -5x plus 3 squared equals 64. So it's all set up to apply the square root property. So we get -5x plus 3 equals positive and negative square root of 64. And then -5x, we'll subtract 3 from both sides and also simplify the square root of 64. And then I'm going to write -5x equals -3 minus 8, which is -11. And the other one, -5x equals -3 plus 8, which is +5. And then in each of those, divide by -5 on both sides. So divide both sides of this by -5. -11 divided by -5 is +11/5. And then divide both sides of this by -5, we get x equals -1. Hey, there's a little more than 11 minutes left, almost 12 minutes. I want to review the problems to quiz 8 and go through those. If there's time left, we'll look at quiz 7. Yeah, I want to look at quiz 8 because some people are making the same kinds of mistakes over and over again. We had a problem like number 1 on quiz 7, and some of the same mistakes are repeated. So one thing perhaps you could do is look and study the answers to quizzes that I email to you so that you can overcome those obstacles. So the first thing we do is find the restricted values. It turns out that this denominator, x squared plus 8x plus 12, is just the product of the other two denominators, x plus 6 and x plus 2. And so the restricted values, one of the x values that makes a denominator 0 is negative 6. So one restricted value, we say x cannot be negative 6. And then the other denominator, x plus 2, means the other restricted value is negative 2. In general, when solving equations with rational expressions, we want to clear the denominators. By that, it is meant that we want to reduce every denominator to a factor of 1. When the denominator is 1, you don't need to write it. So that's what is meant by clearing the denominators. So in order to do that, we need to identify the least common denominator, which is just the least common multiple of the denominators. And since x squared plus 8x plus 12 equals x plus 6 times x plus 2, the least common denominator is in factored form as x plus 6 times x plus 2. You can write it in factored form, or you can write it in expanded form as x squared plus 8x plus 12. Either way is permissible, but think of the least common denominator as having a denominator of 1. So it might seem contradictory, but the least common denominator, when it's used to solve an equation, the least common denominator is in the numerator. That's how we're going to clear the denominators of the original equation. We're going to multiply every term on both sides by the least common denominator, so that every denominator reduces to a fraction of 1. So in this first term on the left, I'm going to multiply x minus 10 over x squared plus 8x plus 12 by the least common denominator in expanded form. So I'm going to write it as x squared plus 8x plus 12 over 1 multiplied by x minus 10 over x squared plus 8x plus 12. And then multiply each of the two terms on the right-hand side by the least common denominator. This time I'm going to use the factored forms, since each of those two denominators involves one of those factors. So we write x plus 6 times x plus 2 over 1 times 4 over x plus 6. And then we multiply the least common denominator by this term, 3 over x plus 2. So x plus 6 times x plus 2 over 1 times 3 over x plus 2. Okay, so it does look more complicated, but it's going to look a lot simpler after we're finished canceling common factors. So in this first product, the trinomial factor x squared plus 8x plus 12 divided by the same trinomial factor equals 1. So we're just left with x minus 10. This has a denominator of 1, but if the denominator is 1, you don't need to write it. That's what is meant by clearing the denominators. Then on the right-hand side, we're going to clear another denominator, the x plus 6 factor from the numerator divided by the same x plus 6 factor in the denominator. That denominator is cleared. So now we're just left with x plus 2, the binomial x plus 2 times 4. And then finally over here in this product, x plus 2 from the numerator divided by x plus 2 from the denominator we're just left with x plus 6 times 3. This equation looks a lot easier to solve than the original. So we just do some algebra and arithmetic. We apply the distributive property a couple of times on the right-hand side. X plus 2 times 4 is 4x plus 8. And then x plus 6 times 3 is 3x plus 18. So we'll simplify by combining like terms on the right-hand side. So x minus 10, and then on the right-hand side we have 7x plus 26. We'll subtract x from both sides to get negative 10 equals 6x plus 26. And then subtract 26 from both sides. Negative 10 minus 26 is negative 36. Negative 36 equals 6x. And then when we solve this equation, divide both sides by 6, we get x equals negative 6. Okay, but we have to remember what the restricted values are. One restricted value is negative 6, and our candidate for a solution is negative 6. So we have to say that this solution has no solution. This equation has no solution. Okay, all that work just to come up with no solution, but it's an important thing to know how to do in algebra. Okay, well, let's look at the word problem. Okay, so one of the skills is to identify what kind of word problem it is. So let's just read it. Janet traveled 150 miles in the same time that Julie traveled 135 miles. Julie's speed was 5 miles per hour slower than Janet's speed. Find Janet's speed and Julie's speed. The numbers are small enough that you can figure out what the answers are without knowing how to set up a couple of equations. Okay, but the whole purpose of this is to see if you know how to set up the appropriate equations. Equations required in this problem are rate times time equals distance, or speed times time equals distance. And there are many clues in the problem itself that tell you that it's rate times time equals distance. Two distances are described, 150 miles and 135 miles. The speeds or the rates are described, and also time is mentioned. Okay, so we'll set up two equations, one for Janet and one for Julie, each having the form rate times time equals distance. So we get to pick letters to represent quantities that we're supposed to find. We're supposed to find Janet's speed and Julie's speed, or in other words, find Janet's rate and Julie's rate. Okay, well, we have a couple of options. If I say I want X to be Janet's speed or rate, Janet's rate, and Julie's speed was 5 miles per hour slower than Janet's, so for Julie, X minus 5 is her rate or speed. And we know that they each traveled the same they spent the same amount of time traveling. So we can write down the rate times time equals distance equation for Janet. Her rate is X miles per hour. And we'll just say capital T represents the amount of time that it took her to travel 150 miles. And in the same amount of time, T, Julie traveled 135 miles. So I have rate times time equals distance for Julie. But an important detail is that this amount of time T for Janet is the same amount of time T for Julie. So that has to mean t equals t. Okay, so solve each of the equations for t's. So on this one, divide both sides by x. T is 150 divided by x. For this one, divide both sides by x minus 5. So t is 135 divided by x minus 5. But since the two times are the same, our equation, whose only variable is x, is 150 over x equals 135 over x minus 5. Okay, so we're down to about 20 seconds. The least common denominator is x times x minus 5. And I'll just do one more step. When you multiply both sides of the equation by the least common denominator, the x is canceled, so this becomes 150 times x minus 5. And on the right-hand side, the x minus 5 factors cancel, so you just get equals 135 times x. And then you can solve the rest of that on your own. Okay, that's all for today. I'll send an email later today about our Zoom meeting trial run tomorrow. That's all for now.